second part of dimensional analysis here, we're looking at using 2 or more ratio. These are the ones that we would consider to be multi-step. And there's a couple different versions of the multi-step that you'll need to know how to do. And don't worry, we will continue to practice as we go. So, on your sheet, you also notice here gave you a listing of conversion factors. You will never be required to memorize the English to metric ones. The ones that you need to know are between the metric prefixes. You need to be able to do those hops down the chart, going from like kilo to centi or whatever. You need to be able to do those still. But when it's English to metric like that, we will provide you them in the problem so you can use them and you would never have to memorize them. So let's look at this particular example. How many millimeters are in 40.2 feet? Well, it's set up exactly the same way. Start your T-chart. We put our given information in the upper left corner. So we put the 40.2 feet up here. Now, we look at the possible conversion factors that have been given to us to figure out what we can do here. Can we go directly from feet to millimeters? No. But what one do we see that we can get to that will eventually get us to millimeters?
It is feet.
Yes, there are actually 2 routes here. You could do the feet to inches. That's one. You could do the inches to centimeters. And then you'd have to do centimeters to millimeters. That's one way. Another way?
The 3.281 feet to 1. Can't we do that too?
Yes, this is another route you could go. You could do the 3.281 feet equals 1 meter, and then you can do meters to millimeters. So the 3.281 seems to be more efficient because it will only take 2 conversions to do it. You could go the other route. That one's going to take you 3 conversions, 3 fractions to do it. Either one's going to give you the same answer though, so it really doesn't matter. So let's just do the 2 for the first one. Let's start with the 2-stepper. I will also show you how you could set up the 3-stepper here and see that you get the same answer. Either way, I'm taking this feet and doing what with it?
Moving it down.
It goes down, diagonal down the feet. Now, if we're using this conversion factor right here, I'm going to put meters up top. Now, I don't have to figure it out because it's already here for me. The 1 goes next to the meter. The 3.281 goes next to the feet. That's our first step, our first conversion fraction there. Now we have to add another one onto our chart. We're going to keep it going because we're not done yet. We are not at millimeters. We want millimeters. So what do I do with my meters now? I diagonal those down here. And what can I put on top? Millimeters. Because I can do meters to millimeters because I know my, giga, mega, kilo, hecto, deca, base, deci, centa, milli, micro, nano, pico, right? I have this set up on my paper and I can use it to shift. So here's base unit, which is meters, and here's milli. Which one's larger? Base. So base gets the 1, and then we go 1, 2, 3. Milli is going to be 1,000 times 10 times 10 times 10. So I put that in here, 1,000 to 1. Now I'm ready to do my math. So multiply everything on the top, multiply everything on the bottom, and then divide it out at the end. So really, what does it look like? 40.2 times 1 times 1,000 over 3.281 times 1. Now, you could easily take out the ones because those ones basically give you the same thing. So really, what are we talking about? 40.2 times 1,000 over 3.281.
Whoa.
And what do we get for our answer for that one? Some weird decimal, yes, probably.
That's really good.
All right, so we get 12252.3 something, right? We're not going to keep all those digits because we still have to consider significant figures in our original measurement. The original measurement is the 40.2. That is what we consider in terms of significant figures to keep. How many significant figures are in 40.2? 3. So that means in my answer, I only get to keep 3. The rest of this doesn't matter for significant figures, only the original measured value. So I keep the 1, keep the 2. What do I do to the second 2? That goes up, right? Now, what about these two place values? Those get filler zeros. So it's 12300, 12,300 and millimeters. You can always check it by making sure they cancel. Feet cancel with feet. The meters cancel with meters, and we're left with millimeters. So that is that final answer. All right. So it is set up here to show you again how to do it. If you need to re-see it on the PowerPoint, you just keep adding to your T-chart, keep building up. Now, for those of you that were looking at the other way, using the other conversion factors, I can set it up that way too. I can do the 40.2 feet, like so. Put the feet down here and go to inches, using that one, right? 1 foot equals 12 inches, like so. Then I can keep going. What would I put on the bottom at this point? Inches would go down here, and inches go to centimeters. So 2.54 centimeters equal 1 inch. And then my last one here would be to put centimeters down here and go to millimeters. And if you're doing the metric prefixes, what you would notice, 1 centimeter equals 10 millimeters. And then you would just do the same thing. You would multiply everything on the top, multiply everything on the bottom, which is easy because those are all ones, and then just divide by 1. And what you would get is 12,300 when it's rounded to 3 significant figures. So either way works. The first one is more efficient though because it's only 2 conversions. This way takes 3 conversions. But you'll notice feet cancel with feet, inches cancel with inches, centimeters cancel with centimeters, and then guess what? We're left with our millimeters, which is what we want at the end. So this is dimensional analysis. You're setting up the dimensions, basically the fractions, so that they cancel each time. And each one that we're putting in here, like the 12 inches, is equivalent to 1 foot. We can set it up as a fraction because they are equal in value. All right, so now I want you to try this one. Set it up, see if you can do it. All right, let's check, see if you set it up correctly. We put the 3.2 pounds in the upper left corner. That means we diagonal down pounds. Up here, we have pounds that can go to ounces. 1 pound equals 16 ounces. So I'm going to go from pounds to ounces. Now, ounces isn't what I want though. I eventually need to get to grams. So I need to keep going. Now I diagonal down my ounces. Ounces go down. And if you look here, we have a conversion factor between ounces and grams we can use. So insert those, the 1 to 28.3. You'll see the ounces cancel, and ultimately we are left with grams, which is what we want. Then you just multiply everything on the top, multiply it, or divide by the ones on the bottom, and you get the calculator answer of 1448, but because there's only 2 significant digits here, we would keep the 1, we would keep the 4, and then the other 2 become filler zeros. Okay? Now we have one more problem to accomplish that's a little bit different than what we've done so far. And these are the ones that have derived initial beginning points, derived units. So we're skipping down to problem 8. Skip down to problem 8 on your, or on the back. I think it's on the back of your sheet here. Skip to problem 8. This one is slightly different, and I'm going to show you how to do it because it is a derived unit to begin with. We set up our T-chart, that's fine, our initial T-chart. It wants us to do meters per second from 51.2 miles per hour. So, 51.2 miles per hour. How do I write this in my T-chart? I put 51.2, the miles on the top, and I use MI for miles to differentiate it from meters. But I also have the per 1 hour, so the 1 hour has to go on the bottom. This has 2 units in it, not 1, 2 units in it. It's a derived unit. Now, we have to convert both because we have to do miles to meters and we have to do hours to seconds. Okay? Which one do you want to do first? It doesn't really matter. Hours to seconds. Okay. Where is hours? Bottom. If it's on the bottom and I need to cancel it, where does it need to move? It needs to go to the top. So we're going to diagonal up this one. Hours goes up here. And what can I put on the bottom? Do I have an hours to seconds one? We look up here. Oh, yay, we do have an hours to seconds one. So, hours to seconds. We have 1 hour equals 3,600 seconds. All right, so hours are going to cancel, right? Not done yet, though, because we have to do miles to meters, right? So where is miles? Miles is up top, so where do we need to put that? That needs to go down.
How come it didn't go to the first one? How come it went the last one?
Because we decided to convert the hours first. So whichever one you pick first, it doesn't matter which order it goes in, because it will still cancel. So we put the miles down here. And is there a miles to meters up here directly?
Yeah.
Yes, we have miles to meters, so we can just do the direct conversion there. 1 mile equals 6,000, I'm not 6,000, 1609 meters. All right, now miles cancel with miles. Check where your units are. We have meters up top, and we have seconds on the bottom. So are we doing meters per second? Yes, we have everything set up to cancel correctly. Now all you have to do is multiply the top, divide by 3,600, and you should get your answer. What do we get here? What's our calculator answer? So then we can round.
22 point a bunch of numbers.
So yes, we get 22.883. How many significant figures did we start with in our original measurement? We started with 3, so we're going to keep 3. Keep the 2, keep the 2. What do we do to this 8? It goes up, so this is going to be 22.9 meters per second. So you need to have M over S. All right, and just so you're aware, you can click through the PowerPoint. It shows you the steps. I think in here I convert the miles first. But as you'll see, it does the same thing. Looking up here, you're going to convert now the hours to seconds. And make sure the units match. And you get your answer.